going to be an introduction about the CYBORG project, then the problems that I have found in the CYBORG project, the solutions that I came up with, the work I have done for the CYBORG project, and conclusions on how the CYBORG project is going to be in the future. So a little introduction. The CYBORG project is, in essence, is combining human knowledge with artificial intelligence. So from what we have gathered in the past, most of the things that we did with artificial intelligence were like training only the model and nothing else. It was only machine. So Dr. Bowyer came with the idea of doing the combining of these two parts of the human, of the machine and human.
It may have been more than Dr. Bowyer.
Okay, a lot of people. So how do we incorporate human knowledge into a model? What they come up with is creating a loss function to tell the artificial intelligence what it's doing wrong. Because sometimes, and I used to think this too, most of the time we think that what the machine sees is the best option, but sometimes humans may have the best option for the machine. So they obviously, I assume you know, they train a model with the normal stuff, and then they started to get annotations from humans. So the first thing they did is create a website where they could do annotations on human faces to detect if the face was real or it was a fake face. So as you can see here, they have a left image, right image. You select which one is the fake one, and then you annotate like in the face. Yeah, this is the part of the face that I recognize that it makes it fake. So, working with the CYBORG project for these 2 months, I have found 4 principal problems that could affect the efficiency of the model. So the thing is that the model is made to get the best out of the machine, out of the model, but it doesn't get the best of the humans, because now, as in the first problem, the humans and how the humans interact with the image are the new limitation. So the way that the CYBORG method is proposed causes the new limitation and has to be like, I don't know how to say in English, but it has to be like properly found, for saying something like that. So, and now it doesn't depend on the algorithm, it depends on how the humans perform. Something that I noticed too with my knowledge in neuroscience is that the annotations are not very registered in order, and most of the time humans tend to fixate their eyes in what is more odd. So imagine if you're looking at a beautiful sunrise or saying something, and then out of nowhere there's like a weird tree. You're gonna see that first. It's gonna be instantly. There's no option to select image. Something that happened with the annotation tool is sometimes that there was these 2 images, but one image looked really fake, and they were asking for the real image. So you know the other one is fake, but you don't know which areas to select of the real image because it's obviously the other one is fake. So, and another problem was that there's no amount of loss defined. What does it mean? What does this mean? The thing is that we don't really know which amount of loss of CYBORG and loss of classif, the normal model stuff, should be incorporated. So, with my knowledge in neuroscience, I presented a neurofield experiment to get the best out of humans, and this can be implemented in any type of annotation or any type of project that requires human intelligence. So, yeah, if I could later, then maybe not, present the other presentation that I had. Humans tend, because the papers are there, humans tend to get more worthiness out of something if they get a reward. That's like kind of obvious. If you do a work, you want to get something out of it. So if a human detects that it's going to get $10 no matter what is the result, it's not gonna perform better or it's not gonna perform worse. So if you make the human like, okay, if you get the face right, you're gonna then get $2 more. Then the human is gonna be like, okay, I have to do better on this task, and it's gonna start to learn, and it's gonna start to do a lot of stuff on consciousness. And so it's important to have this in mind when doing projects about with human saliency and that kind of stuff. Implement annotation order, that's pretty simple. Just put the counter that makes this is the first annotation, this is the second annotation, this is the third annotation, and that's going to make a lot of sense because we can make the algorithm more efficient. Because when we, as I told you before, when we look at something that is more important, maybe the AI can identify that as more important. The option to select image, just pretty simple. Select which is the real image, which is the fake image, and give us what I have started. I haven't tried this beforehand, but the implementation of cyber laws has seen an increase in the efficiency of the model. So what I studied in math, the most probable result is that implementing more cyber laws into the model is going to present a lot more efficiency. Why, you will ask? The thing is that because of how to explain it, the model started to look at areas that it wasn't used to look at. So when we implemented the model with 0.5, it started to look a lot of times to that areas. So if we implement more of the cyber logs, it's going to be more focused on those areas that are important. Just telling about what work I have done. I combined all cans that came from the CYBORG models to create like a summary of all cams combined, and that's going to be in the next slide. And I'm going to explain to that a little more further. Made a proposal and presentation for future CYBORG papers and journal papers on how to do annotations better. There were feedback. Well, still trying to find the best value between cyber laws and classic laws. And I'm now starting to search new implementations for the CYBORG project. As I told Dr. Bowyer, maybe it could be in food sorting equipment, maybe it could be in natural language processing by telling the user, the model, which parts of the conversations are wrong, which parts don't make any sense. So this is the most incredible stuff out of the project. It doesn't look very well with the projector, but as you can see here, this is the CYBORG model in action. So as you can see there, the cam is all over the place. The model doesn't know what it's looking at, and it's doing a generalization of everything. But when we compare it to the CYBORG model, you can clearly see that the model is focusing in what the humans saw. The eyes, the nose, this kind of T that forms in our face. That most of the time indicates which image is fake or real, because it's most of the time it's the parts that the model gets, the generative model gets wrong. What we can get out of this is that finally human saliency is really important for future models, and it should be implemented in most of the AI models in the future. Well, just to finish my presentation, CYBORG is possibly, and I believe, is the future of AI. I'm just going to read that because it's really important. We have come to a stall in terms of efficacy for AI models. We have made models that can perform new tasks, but we haven't been able to create models that are more efficient in the tasks they already do. So CYBORG proposes a new way of looking at artificial intelligence. It's not only now a machine, unknown machine, it's machine combined with humans. And that's pretty exciting for the future of AI. That will be it. Thank you for everything.